Hi there, my name is Mark Townsley. I am a fellow at Cisco and chief architect of Cisco Secure Connect. This is our unified SASE offering at Cisco, and I'm here with Vinny Parla.
I'm Vinny Parla. I'm a principal architect in the Cisco Security CTO office, and I'm the architect of our Zero Trust network access solution.
Thanks, Vinny.
All right, Mark.
So I'm going to kick it off by talking about Cisco Secure Connect and how this new capability fits in. And then I'm going to hand it right over to Vinny because he's going to do the deep dive on this new capability. And that's the agenda that I just said. So Cisco Unified SASE with Cisco Secure Connect. This is a full stack in the Meraki dashboard SASE that gives you really the best of both worlds of SD-WAN and SSE together in one SASE service. We aim to interconnect everything with security everywhere. One new part about this, I came to and talked to you guys a couple of years ago when we launched Secure Connect, and the backbone of the service was running in the umbrella cloud. That is still the case. However, we've added capabilities from Cisco Secure Access. Cisco Secure Access is Cisco's standalone SSE service. Okay, so I want to make very clear, you're going to see more and more of the Secure Access capabilities, which is a standalone SSE, embedded into the Meraki experience as part of the overall SASE service. Okay. As I mentioned, we run in the Meraki dashboard. When we launched a couple of years ago, when I was here talking to you guys, we had this swivel thing. There was an overview page in the Meraki dashboard and a bit of a swivel over for certain firewall features and such. What we've been doing is bringing those in natively into the Meraki experience so that you don't have to switch around so much and you can have access to the information that's available in the Meraki dashboard for a more unified experience. So all of these capabilities that you see listed there are now capabilities that are natively in the Meraki experience with APIs as well as the UI. As I mentioned, we're running in Cisco data centers around the world. These are our own data centers. There's 33 of them right now all over the globe. We're adding more. And when we add in Secure Access, which has virtual points of presence in public cloud, we'll have those as well. This is what the overall architecture is of what is running in those POPs. And what you see is basically this premise of interconnect everything. You have your auto VPN, Meraki MXs, you have your Catalyst SD-WAN, you have IPsec tunnels, you can have clouds, you can have a variety of different types of users connecting in with VPN, with proxies, etc. All of them connect in and have access to the security services inside those data centers running all as a service. Now I'm going to go through some of the ways remote users connect in. The first is classic. It is your client-based VPN. It's AnyConnect, if you will, but we're not allowed to say AnyConnect anymore, so it's a Cisco Secure Client, okay? It's, you load it up, you are part of the network, you get an IP address from an IP pool that are in different regions, depending which part of the cloud that you're connecting into. But once you connect in, you're part of the network and you can reach all those services, except we also put a firewall in place in front of that VPN, and with a default deny for least privilege access. It gets a bit like zero trust. Vinny won't let me call it really zero trust, but it's a bit like that because you can limit access on a per user basis to the resources that they're allowed to reach in that network at the firewall, okay? So it's part of that whole zero trust journey. Another way, which is the other end of the spectrum, no client, no AnyConnect, no Cisco Secure Client, just a browser. And here we run a proxy inside our cloud and let you connect just web traffic to that proxy to a special URL where we perform a bit of a posture check and give you a splash page to log in. And you can log in with whatever your credentials are for users. And then if and only if all that passes, we initiate the other side of the proxy with a local IP address to the destination application or resource, whatever that IP is. So the traffic simply comes in over the internet through this proxy and to that application and only that application. Again, it's a ZTNA type service, but with no client. And it's not as secure, obviously. Here's the new one though, and Vinny's coming really soon. It's the client-based zero trust. It's kind of the best of both worlds, if you will. The client is not as heavyweight, especially if you're running on a device like an Apple device where we use the actual built-in implementation in the OS, and we just have to do client enrollment. It is also allows more than just web traffic, and it is more secure, but I'm gonna just let Vinny talk about that right now.
Thank you, Mark. So I'm Vinny Parla, as we got introduced earlier, and I'm going to talk about the new Zero Trust Network Access solution. So if you look at this architecture, we basically have in the middle an identity-aware proxy. Everything goes through that identity-aware proxy. So it knows who the user is, what the device is, what the posture of that device is. So if the firewall's off, for example, on the device, it'll know that. And you'll be able to write access policies to allow access to resources based on those artifacts and pieces of information, okay? This is not like any other ZTNA solution. All other ZTNA solutions are just VPNs under the cover, right? They assign an IP, they use CGNAT to obfuscate addresses, but it's an IP packet forwarding system. This is actually a streaming ecosystem. So there's no IP headers, no IP packets. We're actually doing byte streaming over the proxy and over to the resources. So what that gives you is the entity on the left, the client, is completely on its own network. And the addresses that it gets for resources are synthesized addresses. So if you go to, let's say, myinternalserver.com, you're not given the real IP address of that. You're given a loopback address on the client. So there's no way for you, as if you were an attacker and had a foothold on that endpoint, to even learn anything about the internal network. So that internal resource might be on 10.2.3.4, but the IP assigned on that endpoint is not that. It's just going to be a loopback address picked randomly. So it's completely random. And then for IPv6, it'll be what's called the discard prefix IP address, which is discarded by routers. It's a non-routable address. So that's the big difference here. It's giving you ZTNA capabilities, but it's not relying on underlying per-app VPN like all other ZTNA solutions that are out there. Okay, so what is MASQUE? MASQUE is really a collection of two protocols. It's HTTP2 and HTTP3 forward proxying. And it has the capabilities to proxy UDP and TCP traffic. So if you remember proxies from a long time ago, you would have to have something like a SOX proxy to do UDP, and you would have a traditional proxy to do TCP. They've now been merged essentially, so you can do UDP and TCP in the same HTTP protocols. And this has a lot of advantages. One, faster setup. With QUIC and HTTP3, it has resiliency just like a DTLS or IPsec VPN. So if you're on a lossy network like an airplane, it's very resilient. You're not doing TCP, low-level TCP retransmissions in that case. And you can do very fine granular application controls inside of these protocols. And I'll get to that in a second. Okay, so this is what it looks like. You have the client on the left, your identity-aware proxy in the middle that we talked about, and a server on the right that you're trying to reach. And we are going to securely stream over an encrypted channel. So this is not a tunnel, it's a streaming protocol. And the way it looks internally on the protocol is you have basically reliable datagrams and unreliable datagrams. So reliable datagrams replace TCP. It does all the functions that TCP would do, but now it's doing it inside a UDP protocol, QUIC. And inside of that, it will do things like retransmission, congestion control. All the things that you have in TCP are now moved up into QUIC. And QUIC is an encrypted protocol. So essentially, you're always doing TLS, right? So there's no like QUIC in the clear like in the old days of TCP with HTTP. So this is all encrypted traffic. Okay. One of the biggest features of the MASQUE protocol is it inherently has microsegmentation built into it. And that's a very important principle in zero trust. So the way it works in our solution is it's all process-based multiplexing. So that means if you have Chrome and you're trying to access resources, all of the Chrome traffic is put in its own separate MASQUE stream. If you're running Firefox at the same time, it's a separate MASQUE stream, okay? And you are now able to microsegment all the way from the source application to the destination. So you can have very fine-grained controls around that, right? So if you have a policy and you don't want Firefox to go to your finance server, you can set those policies and you're guaranteed there's no way that that data ever is going to be intermingled. They're separate sessions. Okay, so this is how the microsegmentation works in QUIC. There's something called the quarter stream ID, and that's basically a multiplexing protocol. So you can have many of these stream IDs inside of one session, and each one of those stream IDs will be associated with a destination. So stream ID 1 will be www.cisco.com, and stream ID 2 will be finance.cisco.com as an example. Each of those streams are separated and annotated, and when it reaches the identity-aware proxy, it can apply a policy to each individual stream. So we can say, okay, stream 1, well, on this device, you're not allowed to go to the finance server. So we're going to reject that and send back a response back to the client to say, you're not allowed to access. Okay. This is built into Apple OSs. So we worked with Apple for almost 2 years, and this is actually natively built into the OS using network relays. And the project we worked on was called Enterprise Relay together. So this is actually part of the OS. So what we're providing, you'll see this architecture will be similar in all of the systems. But in this case, all of the proxying client functionality is built into Apple's OS. We're just the provisioning client. So what we do with AnyConnect is the onboarding. So a user will open up the AnyConnect client on an Apple device. They'll enter their credentials like a normal SSO workflow, and they'll get enrolled into Zero Trust Access. And from that point forward, the Apple OS is doing all of the traffic steering.
When you say Apple OS, we're talking iOS and Mac OS?
It's available on iOS and Mac OS. Today, we're only supporting iOS currently. So we have our own Mac OS client with AnyConnect. So, but the functionality is in both OSs.
So, odd question, but Meraki does have stuff for Apple TV, tvOS as well, or no?
It's available on tvOS, but we don't have an enrollment client for tvOS at this current time. So you just have an enrollment client in the App Store on iOS. And part of what we do in enrollment, and the important thing on the right of this picture is your identity when you do an SSO enrollment gets baked into an identity certificate. And that key for that certificate is in TPM, or Secure Enclave is what it's called on an Apple device. Can never leave that device. So when you do an enrollment on a device, let's say you enrolled on this device, that will have an identity certificate for you on that device. It can't be used anywhere else. So unlike other types of issues where you have credential theft with tokens, man in the middle, all of those kind of things, it's not possible to do. So we do a protocol called DPOP, which also uses the TPM and binds everything to that device. So where you start your enrollment and do your enrollment is where your Zero Trust Access is going to be enabled. What you'll see is we also support Samsung devices. Samsung is almost the same architecture. They built the framework to do all of the traffic interception. We wrote the part to do the mask encapsulation. So in the case of Apple, as I described earlier, 99% of it's in Apple's OS. Here it's a 50-50 split. So Samsung intercepts all the traffic on the device and forwards it to our client. we then encapsulate it in MASQUE. But again, in the same solution, it's exactly the same architecture with a TPM bound certificate. So when you do your SSO enrollment on a Samsung device, your identity certificate is still bound to that device in a TPM. And then to cover over the remaining platforms, Windows and Mac OS currently, Linux is planned for the future. So on Windows and Mac OS, it's all AnyConnect implementation. We wrote the kernel drivers to do the same thing that Apple and Samsung are doing. We bring it up to our client. We do the MASQUE encapsulation. So the architecture is exactly identical. And again, everything is TPM bound. So yes.
And it can leverage the start before logon stuff on the Windows side?
Everything is post login, so it's not like VPN. So it's essentially designed for user interactive sessions, right? So you're accessing a resource, proactively acting as a user, accessing a resource. That's where zero trust comes in, right? So any of the things that are like pre-login, like your Windows login and things like that, are not supported in zero trust access currently. Again, that's something for the future that we do plan to support.
So it's going to make you essentially re-authenticate to every resource you're trying to get to?
No. So that's all policy driven, right? So based on the administrator policy, they may just use the identity certificate and you won't be challenged at all. So it'll be much closer to like an in-office experience, right? So it'll be transparent. There's an authentication going on with that identity certificate, right, on behalf of you, but you're not asked to, enter credentials. Now, they can enable something called step-up authentication, and what that is an additional challenge. So you may have like an SSH server to your infrastructure, and you don't want anyone accessing that unless they're doing like another authentication, maybe a biometric authentication, right, in addition to that identity cert. So that's a policy decision.
So where does the identity cert come in?
All of the connections that are made are done with an identity certificate that essentially is acting as you, as the individual user. So when you did that first enrollment, your enrollment from SSO is baked into the certificate, and then under the covers, it's every connection that's being made, it's handing that certificate off to the proxy.
So that enrollment happens every time you access, or just once?
Just once. And then if your certificate ever expired, you'll get put back into an enrollment workflow.
So this is the piece I'm not putting together. So if I've enrolled, someone else comes into my laptop, they have access to the kingdom?
They potentially could, sure. Yep.
So on the secondary,
then if you're worried about that, you would add step-up auth. You would say challenge for biometric auth for every one of these connections. It's a policy decision. How much, user interactive authentication you want to have the user go through is a policy decision. So you could, for every connection, say, sorry, do Face ID.
The thing I'm just worried about here is if it's not if there's no link to the initial login and it's just an initial enrollment and trust, then someone gets my laptop, opens it up, logs in, and they just automatically have access to everything that my laptop would have access to.
Sure.
It's not exactly a zero trust.
well, hold on.
The application still has the block. It's just the same as if someone grabbed it inside of the office.
Right, but that's still based on the identity certificate, which is there once it's enrolled.
The application is in the one that you're reaching out to. So if you were reaching out to like a controller that was on-prem, that session is established, that token is used, correct? But then the controller still has its login page that you would go into.
I see.
Yeah. Any application level authentication that is part of the application, you still do.
Okay.
This is essentially zero trust network access is about getting packets to the server, right? So any application level protocol is above that, right? So in zero trust network access, you're basically saying, don't even let them send one packet to that server unless they're
fair
identified, right? But again, for every single one of these flows, you can challenge the user to do biometric auth. If that's your corporate policy, like you're going to SSH, you're doing biometric auth before a single packet hits that server.
And that identity certificate is held in the user profile?
The identity certificate is in the user profile. The key is in TPM.
Okay, so someone else logs in as another user. It's not like the machine is authentic.
No.
Thank you.
And a quick question on the second authentication mechanism. You keep saying biometric, but can you use hard keys, for example? Do you have a variety of choices?
SAML-based authentication method.
Okay.
So it's all SAML-based or OIDC, either one.
Just a reminder of where this all fits in. Cisco Secure Connect is Cisco's unified SASE offering. We are bringing in more and more capabilities from Secure Access. Secure Access is our standalone SSE offering. Okay, this is one of the, what Vinny was talking about, one of the exciting new capabilities inside Secure Access that you now see. We have a private preview with customers now. It'll be coming out over the coming months as part of your Cisco Secure Connect subscription. You don't have to buy anything else or anything. It's just going to be there. You can still use your old school VPN if you need to. You can still use the client list. All of them are available, and you can bring on this the new zero trust network access, client-based zero trust network access when the time comes. Any more questions about that or about Secure Connect in general? We can bring back Vinny as well.
One question you might have said, what devices can act as the ZTNA proxy?
You mean on the client side?
In the infrastructure.
In the infrastructure, it's a proxy running in our cloud, and it doesn't really care which. I'm not sure what the question is.
So like it's just within the cloud that there's no like physical on-prem component that needs to be there.
No.
None of this is in the user cloud either. It has to be in your cloud.
Yes. It's in our
Okay,
cloud.
understood.
Yes. The entire SASE offering is like that. Same for when we connect like Meraki SD-WAN MXs to the cloud. We have our own head in there that we connect in all those tunnels. And then after that, it's normalized. We kind of don't care what type of tunnel is being used at the edge on the inside.
So once this is all connected, everything goes point to point.
It depends on what you're doing. For the new capability, it's very granular, right? It's like you're, as Vinny said, you're connecting from the application down to, some specific resource inside your infrastructure. For the SD-WAN connectivity, or if I have an IPsec tunnel and a catalyst, I can actually interconnect all of those, and that's doing full routing.
Okay. But this architecture, all user traffic goes through the Cisco cloud.
Yes. Okay. Absolutely.
Thank you.
Yeah, I would just qualify all split include traffic that you want part of the cloud security infrastructure. So you can have certain things that you just say go directly to the SaaS service.
Right.
Yeah.
Right.
But
Excellent
everything that's covered specifically by the zero trust tunneling
Yes.
goes through that cloud.
Yep.
Okay, got it.
Yeah. And for the SD-WAN connectivity, all of the sort of split, like we call them VPN exclusions inside Meraki, I believe, you can split out your Office 365, whatever. So yeah, it's some of the traffic goes to the cloud. The rest, the traffic that doesn't need the interconnectivity or what have you, doesn't go through the cloud.